Alexa, reverse.
Neutral. Going into reverse. Now in reverse.
Alexa, forward.
Neutral. Going into forward. Forward.
Alexa, speed 1. Alexa, speed 2. Alexa, speed 3. Alexa, speed 4. Alexa, speed 2. Alexa, speed 1. Alexa, speed 3. Alexa, speed 2. Alexa, speed 4. Alexa, speed 2. Alexa, speed 1. Alexa, cycle.
Cycling.
Alexa, cycle.
Cycling.
Alexa, forward.
Neutral. Going into forward. Forward.
Alexa, speed 2. Alexa, speed 3. Alexa, speed 4. Alexa, speed 2. Alexa, track power off. Alexa, switch right. Alexa, switch left. Alexa, switch right. Speed 1. Alexa, speed 2. Alexa, speed 3. Alexa, speed 4. Alexa, speed 3. Alexa, speed 2. Alexa, speed 1. Okay, so what's going on here? How am I powering everything? Let me just show you what I have set up here real fast. I have hooked up to the track some lights just to give a little bit of a load. These are 14 volt lights in series hooked up to the track, no train on the track. And here is the Sonoff 4-channel Pro right here, and the multimeter, of course. And the switch, how the switch is being done here would be these three contacts, the taps for the switch, they're fed into the Sonoff over here. And the green wire, from here, the ground is fed into both of them and jumped with this little red one over here. Essentially, I'm just putting them through the relay, two relays here on the Sonoff that are set in a momentary, they call it an inching, it's a momentary mode. These other two are set in self-locking or typically a locking mode or latching mode. We would call it a latching mode. And so what's happening is that these diode strings, which are just pairs of diodes back to back, in other words, I say back to back, one diode facing one way, one facing the other, so it's passing AC. Diodes, of course, pass only DC, but back to back this way it'll pass AC, and each diode will reduce voltage by approximately 0.6 of a volt. And so a pair done this way will reduce the voltage going through them, AC voltage, by approximately 0.6 of a volt. And so I have a string of 13 diodes. It's tapped at the fifth diode over here. So in one way, 5 diodes are into play. The other way, 8 diodes are into play. And the fourth way, all 13 diodes are in play. So the lowest speed would be 13 diodes in play, and the fastest speed would be no diodes in play. In other words, I jump all the diodes. And that's what these connections are. They're essentially jumping a group of diodes, either jumping all of them, jumping the 5 of them, or the 8 of them. And that's how I'm doing the crude voltage reduction. It is crude. Why are they bolted together? Why am I not using a terminal strip? The bolts act as heat sinks. All of the voltage is being dissipated as heat. So if you're dissipating, 10 volts, you've got 10 volts of heat. The bolts act as really good heat sinks. So you can tighten them. I don't have a lock washer. You should have washers on a lock washer in here, but just for my purposes right here, because this is for people who don't want to solder. They are difficult to solder anyway. You can make this a tighter configuration. I just have it here for demonstration purposes, a more visual way of doing this. And I'll have a diagram of this whole circuit and how I did it. This Sonoff is not being powered by house power, although there are connections right here to power through either, I think you can go up to 250 AC, but I didn't want to put full house power through it. I have it powered through a little wall wart right here, pardon my hand, wall wart right here, and that's how I'm doing it. Essentially, the way this is set up, and I'll open this up later and show you inside, because you have to set there's some dip switches you set and one switch that you set in there. It's no soldering, just a little screwdriver. You flip the switch. So how this is doing it, and you can let me see if I can do it without putting on Alexa here. If I hit the 1 button. So if your Wi-Fi is down, you can still hit these buttons. You're not dependent on your Wi-Fi. If you're worried about your Wi-Fi, or you're worried about Alexa eavesdropping on you. And
Sorry, I don't know that.
You certainly don't. Okay, so I'm going to mute her here. So, and these two are the ones that are in locking mode. And you notice when I hit this relay 1, this is essentially speed number 2. If I add if I turn this one off and I go to this one, this is speed number 3, and then both of them on is speed number 4 or speed 4. That's how I have it set. And if you vary the input voltage on the transformer, obviously you can get that down. So when all the diodes are in play, as here all the diodes are in play, you can get as low as whatever you want out of the transformer, because you could even get as low as 1 volt. So if you're running HO or something that needs only DC power, you can put a rectifier and capacitor on this, and you could also feed DC through this. This diode technique will pass AC or DC. It's not DC polarity specific. So this is a very simple technique, and these diodes are a little hard to work with. They're a little the wire is a little stiff, and what I do is I bend them like this. I can make that. I bend them like this, a little loop on either end, and then they can bolt together. One diode facing one way, the other diode facing that way, so both cycles of the AC are passed, and this diode would reduce by approximately 0.6 of a volt. That's how we're getting the voltage reduction. So the sewn off here, very nice terminals. You just push down on them. You feed your wires. You do have to strip wires. There's no solder. The whole project is no solder, and we get our variation in speed based on how which relays we put into play. You are using Alexa routines to turn off relays and put them on, but anyway, you can. It's a very simple thing to do, and that's my setup here. So in the routines, I am controlling which relays are on and how are these set, and I'll show you in a second how this is set inside. I'll open this up in 1 second here. So I'm going to unplug. I'm going to turn off the power to everything here, and here's the little barrel jack, how I have it. My hand is in the way. I'm going to unplug this barrel jack here. Unplug this over here too. And here is and I'll also unplug Alexa. So here is the sewn off, and let me get this in the camera better, and I'll push this all aside here. Okay. So what we're doing here is that I'm going to leave these all connected. This is a better view of the diodes here, the diode string. It's just a string. I just did it in 2 loops, but you can make them compact and put them in a project box. So this is the sewn off, and I'm not going to disconnect any of these here, but you can just see briefly how I have them connected. These are the wires from the switch. This jumps the ground over to the common of both. So the green is the ground, and these are the 2 switches, 2 wires from the switches right here. Get it into frame there. And this is where you would put house power if you wanted to put house power in, but I use the barrel jack over here, and then these are I'm just jumping the diodes. So let me take the screws out of here real fast. And the screws stay in there, so I just leave them like that. They don't get lost. And I'll turn my multimeter off here too. Okay. So this is the board. This shows you here are the 4 relays, and so if I were to power this up, you would see the LEDs in here, but I don't like to handle it even if it's powered low voltage. I don't want it full. So how do you set it? So this actually comes out of here. So we can put that aside. And on the back of this, they show you the table, and I have it upside down. They show you the table, but the instructions are easier to read than this. So all you're doing is you're taking, and let me get this in frame. This switch right here, you want to make sure this is switched, this is pushed as you're facing it, the board this way with the LEDs on this side and the relays at the top. This switch, you want it to be switched to the left, pushed to the left. And these little dip switches right here, they have to be set in this the configuration here, and I'll do a little diagram. I don't know if that's going to be in focus with the webcam, but let me see on mine. So this configuration sets this particular set of dip switches sets the momentary mode to how many seconds it's on, and this sets the two to self-locking or latching, and the other two to momentary. So you don't have to worry about anything. All you have to worry about is just matching this. These three are up and this one is down, and over here these two are up and those two are down, and I'll make a diagram of that. So that's all you have to do. You open this up and you switch that around, and you have these two as momentary and these two as latching. So this configuration makes these two momentary and these two latching, and that's essentially it. And that's all you have to do. It's very simple to do. And the hardest part, I should say the hardest part, it's time consuming to set these little diode strings together. It's a little, you just take your time. Maybe someone who's familiar with bending little things for making jewelry or something could do it for you. Someone in your household can do that. But I just bolted them together. Again, use lock washers and lock nuts and whatever, lock washers and nuts. And then you can also have you can bend this any way you want. Of course, I said this sewn off is very easy to set up. Don't be intimidated by it. There's no soldering in this project at all. But this is the reason for the diodes. If you're running older open frame motors, you want pure sine wave in the older equipment. The chopped AC waveform is not kind to the older motors, so you want the older motors to have as close to pure sine wave. So if you put this through an oscilloscope, it really is almost a pure sine wave. I mean, it's not a chopped waveform. It comes through on my inexpensive oscilloscope as a sine wave, pure sine wave. Certainly not a chopped waveform, but this is very kind to the older motors, and it's what you want to use. Very simple setup, not the perfect setup. In practice, you maybe only need 2 speeds, a fast and a slow. When your equipment is cold, it's a little more sluggish, and then you would take it down. And of course, you could also blow a whistle. You could make a whistle circuit up out of diodes, and you could use one of these set up in a momentary mode with the Alexa app to blow the whistle as many times as you want, and set that up. And I'll do a little thing later on blowing the whistle through this. But that's essentially it. The 4-channel Pro, Sonoff 4-channel Pro, and the other one here was the basic Sonoff from the other video, which I like a whole lot. This one, because there's, again, for people who don't want a wire or anything, there's no you're not splicing into full house power. Same way with this, we're using a wall wart. We're powering off of a wall wart right here, and it's a very simple and safe way to do it, especially if you have children that may be opening it up. And it's very easy to pair this initially. I shouldn't say pair it, I should say set it up initially with the eWeLink app. And again, we have the buttons here. These are set momentary, and these are set as latching. Very easy. And again, you can run this manually if your internet goes out or you don't want to do internet. You also have an option for key fob radio frequency. You can turn these on and off from the key fob. So if you don't even want to use Alexis, you can work with a key fob, and I'll put the link to that in the description. So that's essentially a diode string reduction, crude but safe, effective, almost a pure sine wave out from this. In fact, it looks like a pure sine wave. You just have the reduction of the voltage, and it's kind to your older equipment. The diode trick is a very good trick to reduce voltage from a fixed wall wart. And this configuration will pass AC or DC, DC of any polarity, and of course AC. And so, the very good trick, very good technique, and simple to do. So, that's it.